All right, now we're on lesson 5 for Algebra 1. I am on page 23. In this little section here, we're talking about sets. We're talking about sets of numbers. So here we're talking about natural numbers. Natural numbers are kind of like counting numbers, where you start with a 1, 2, 3, 4, 5, 6, and you keep going up and up. And if they ask you to draw what a set of natural numbers looks like, this is what they're asking you to draw right here. This little bracket, the 1, 2, 3, 4, 5, and then these dots, and then another bracket. These dots are indicating that this number set continues and it keeps increasing. So this includes 6, 7, 8, 9, 10, all the way to positive infinity. Okay? Whole numbers are just the same thing as natural numbers, except for they have a 0. So they're 0, 1, 2, 3, 4, 5, ... and it continues to infinity. Neither one of these contain fractions, decimals, negative numbers. These are only positive numbers, positive integers, and this one starts with 1. Natural number starts with 1, and whole numbers starts with 0. Okay? Now, if we include the negative numbers, if we look on the next page, this is what it's called. They're called integers. Integers are negative. So here they're going to start with dots, because you can go from negative infinity to over here, positive infinity. So it includes all the numbers below -3 and all the numbers above +3, all of these included in here. Okay? All of this is saying, with your natural numbers, whole numbers, etc., is saying every integer is going to include the numbers negative infinity all the way to positive infinity. Okay, so it's just telling you which numbers are integers, which numbers are whole numbers, which ones are counting numbers, etc. Okay, so as we continue in our lesson number 5, we are talking now about absolute value. Absolute value is basically saying what is the distance from that number to 0 if you're on a number line. So let's come over here, right here, how this 0 is here. From -4 to 0 is 4 units. 1, 2, 3, 4. From +4 to 0, it's 1, 2, 3, 4. So if you had the absolute value of -4, it would be 4, a positive 4. The absolute value of a positive 4 is a positive 4. So let me show you some examples of what that looks like. So the absolute value of 0 is 0. There's not a positive 0, there's not a negative 0, it's just 0. 0 is nothing. Okay, B, we have a -7 and 12/100ths in these absolute value marks. That's what absolute value stands for right there. It's a positive 7 and 12/100ths. So if you were going to come over here and you had a -7 and 12/100ths on your number line, it would take you a positive 7 and 12/100ths to get back to 0. So that's where this positive comes in. So anything that's in the absolute value is going to come out as positive. Doesn't matter if it's a fraction, a decimal, a whole number. Here's a -5. It's going to come out as 5. This is saying the absolute value of -5 equals 5 or is 5. Okay? They say that up here. Right here, this -7 equals 7. You read that when you look at it, you say the absolute value of -7 equals 7. So the absolute value of -7 equals 7. Okay, so here's some more examples up here on page 25. Simplify the absolute value of -5. Well, that's easy. What is the absolute value of -5? Well, what's the positive? It's 5 right here. Then we have this one, absolute value of 11 minus 2. Okay, well, 11 minus 2 is 9. And the absolute value of 9 is 9. You have to do what's inside of it, inside of the absolute value first. So if this had said 11 plus 2, you add them together. 11 plus 2 would be 13. The absolute value would have been 13. Or you could have times them together because it said times, 11 times 2, and you would have gotten 22. And then the absolute value of 22 would have been 22. But you have to do what's inside the parentheses, not the parentheses, I'm sorry, inside the absolute value sign before you take the absolute value of it. Okay? Down here, we have something that's a little trickier. We have the absolute value of 20 minus 2, but then we also have a negative sign in front of it. So 20 minus 2 is 18. So we'd really like to be able to say, all right, well, let's take 18 out of there and just keep it all positive. But what we have over here is now we have a negative absolute value of a positive 18. Well, the absolute value of 18 is 18 positive, but you can't just ignore this negative sign. You have to bring it over here. It's kind of like saying negative 1 times positive 18. And negative 1 times positive 18 would be negative 18. So even though it started out in the absolute value here as 18, because the minus sign, the negative sign is here, you have to keep it in your answer. Okay, so this is not going to be a positive number. It's going to be a negative number. Okay, so in the book, they're talking about adding negative numbers together, or signed numbers, some of them being positive, some of them being negative, and they use number lines and they direct the numbers. Sounds kind of confusing, but it's kind of simple. So in example 5.2 on page 26, they have this number line here, and they start at 0 and they say, okay, we're supposed to be adding a positive 3 and a negative 5 together. So they're going to go start at 0. They're going to go positive to the right 3, because positive is to the right in a number line. Okay, anytime that you're adding something, you go to the right. And then they're going to say, oh, now we have to go backwards from here. 1, 2, 3, 4, 5, because that's negative. A negative direction is to the left. And they're going to say, okay, well, a positive 3 and a negative 5 added together is going to be a negative 2. So they actually draw this whole big box all out here. Okay. Then they're going to do the same thing for a negative 5 and a positive 3. So again, they're going to start at 0. Okay. And they're going to go backwards 5. 1, 2, 3, 4, 5, because this is a negative and you go to the left on negatives. And they're going to say, okay, well, at negative 5, we have to go positive 3 now. 1, 2, 3. To the right, and if you go down, that's going to be at a negative 2. So a negative 5 and a positive 3 added together would be a negative 2. Okay, over here, we've got another one. Use directed numbers in the number line to add positive 2 and positive 1. Well, this one's pretty easy because you start at 0 and you're going to go add 2, 1, 2. And there you are at the 2 section here. And then they're going to say, oh, now you got to add another positive 1. So you're always going to the right. And then you end up with 3. Now, it's easy to just say, well, why didn't we just say 2 plus 1 equals 3? Yeah, that's great. They just want to show us how that looks on a number line to help us to understand how adding and subtracting negatives work, and how you're going positive one way and then negative another way, and how it all ties together. Okay, I'll show you one more example here. Let's go down to here on the bottom where they have a lot of numbers. Okay, and so they start with negative 4. So again, they're going to start at 0 and they're going to go backwards 4. 1, 2, 3, 4, so that they're at negative 2. And the next thing that you see here is the positive 2. So they're going to go from this negative 4 and they're going to go forward 2. So now they're at negative 2. But now they're asking, okay, well, now we have to go backwards 1 more from where we are. And suddenly we're at -3 so far in our equation. And now we're going to add a +5 to where we are at -3. And we're going to go 1, 2, 3, 4, 5. And it's going to bring us to +2. So all of these numbers added together is going to equal a +2. They're going to ask you in your homework to make these number lines. Remember to always start at the origin. Positive numbers go to the right. Negative numbers go to the left.